Hello, welcome and thanks for joining today's webinar session, where our discussion will focus on Ruskin's industrial damper capabilities, supported by relevant case studies. Through Ruskin's monthly Wednesday webinar series, Ruskin promotes product and application-related information that covers a range of relevant HVAC topics, providing our customers with material intended to contribute to your ongoing success. My name is John Haukap, and today I'll be sharing some insight into the design and applications of the more commonly specified industrial damper models, as well as the more customized designs for opportunities that you just don't see every day. It's my privilege to have worked at Ruskin for over 20 years now, with more than 15 years dedicated to the industrial product line. While everyone in the audience will be muted throughout the duration of the presentation, please feel free to type in any questions which you may have, and I'll address your questions or comments after the presentation has concluded. During the webinar session, I'll be offering information on each of the basic damper families, which is determined by the application or intended function of the dampers. We'll discuss the capabilities of the models and how these capabilities bring about opportunities in the market. I will then highlight select case studies which represent success stories associated with select damper models. And finally, we'll conclude the webinar by answering any questions which you may have entered during the course of the webinar. So Ruskin offers a broad selection of solution-based products for industrial applications. Some of these products include dampers for industrial control processes, which include multi-blade airflow control models such as our CD80 and CD30 series, and round single-blade airflow control models under the CDR series of dampers. Dampers for backdraft and pressure relief, which include multi-blade models such as the CBS series of dampers, and true round models such as our NRBD 100 and the CBDR series of dampers. Dampers for system isolation, which include models for low leakage applications within the CDRI series of dampers, such as the model CDR-I92. For applications where it's critical importance that isolation of the airstream is achieved, engineers specify bubble-tight performance. You'll see these called out in specs for labs, clean rooms, and medical facilities, to name a few applications. Dampers for blast suppression, specifically a damper model CBSSBL. That's designed to react to and suppress the propagation of an elevated pressure event caused by typically dust cloud or vapor cloud explosions. And dampers for industrial life safety applications. Specifically, this means targeting installations in transit tunnels, used for introduction of natural ventilation and diluting carbon monoxide in the tunnels, for isolating the fans which force airflow into and out of the tunnel, and for emergency fire and smoke control in the event of a tunnel fire. Underground transit tunnel projects, whether they be for vehicles or for mass transit, offer Ruskin a distinct advantage over our competitors because we can marry our industrial life safety dampers with our sound attenuator products to offer customers a more efficient proposal package. And lastly, Ruskin's portfolio now includes both round and pultruded multi-blade dampers constructed of fiberglass reinforced plastic, or FRP, for highly corrosive applications such that you'll see in wastewater treatment plants and in microchip manufacturing facilities. Ruskin's multi-blade air control products include the versatile induct-mounted CD30 series dampers. The CD30 series is characterized by a narrow 3-inch deep, 12-gauge galvanized steel channel frame with blade-mounted linkage and stainless steel sleeve bearings which are pressed into the frame. For applications which require shutoff or otherwise low leakage performance, the CD30 series dampers are available with stainless steel jam seals and a wide variety of blade seal materials such as silicone, EPDM, neoprene, Viton, and even stainless steel, with selection based on airstream temperatures and the corrosiveness of the airstream. The CD30 series dampers are of welded construction, which makes them ideal for installation where higher pressures, elevated temperatures, or airstream contaminants prevent use of a commercial roll form type of control damper. The CD30 series damper is commonly mounted directly into the ductwork, slid in through a slot cut into the side of the duct, and then covered by use of a side plate. Or it's mounted directly to equipment or duct using optional front or rear flange frames. CD30 series dampers are available in multi-section configurations with ship sections easily connected by jack shaft crossover linkage, as shown here, and splice plates in the field. Ruskin also provides transitions for the CD30 series units when multi-blade airflow control is preferred in a round duct application. As standard, the CD80 series of dampers is characterized by an 8-inch deep channel frame with side linkage located out of the airstream and with stainless steel sleeve bearings either pressed into the frame or inserted into cast housing and bolted to the frame. And that just depends on which of the models you select in the CD80 series of dampers. The CD80 series damper features are easily customizable to meet a variety of specs which may be driven by higher pressure, elevated temperatures, project-specific materials of construction, or lower leakage requirements. For units required to provide low leakage performance, much like the CD30 dampers, the CD80 series of dampers are available with stainless steel jam seals and a wide variety of blade seal materials. Also, for projects which require containment of the airstream, shaft seals are utilized to minimize the amount of airflow which might escape through the area where the axle penetrates the damper frame, as you can see here. The CD80 series dampers are available in multi-section configurations with sections connected using through axles or by jack shafting, depending on which damper model is selected. And as you can see here, when multi-blade control is preferred over a true round single blade control damper, the CD80 series dampers are available with squared around transitions for connecting to adjoining round flanged ductwork or equipment. Another multi-blade control damper which I wanted to highlight is the CD102 and the OD102. This damper is constructed using aluminum airfoil shaped blade and utilizes a machined D-shaped axle, which eliminates play or slop between the axle and the blade pocket. This play or slop oftentimes can be seen when round axles are inserted into round extruded blade pockets without the proper mechanical constraints. The D-shaped axle is pressed into the extruded blade pocket and then it's staked in place right there. This extruded blade design includes a slot into which optional extruded silicone blade seals are mechanically locked. The difference between the CD102 and the OD102 is that the CD102 is equipped with stainless steel sleeve bearings pressed into the frame as standard, while the OD102 is equipped with stainless steel sleeve bearings placed in a cast housing and bolted to the outside of the damper frame. The OD102 is especially suited for fan outlet applications where the bolt-on bearings provide greater strength and resistance to the constant vibration under which the damper would be subjected when mounted directly to or in close proximity of a fan. On the upstream side of the fan, inlet box dampers are utilized when inlet boxes are designed into the fan configuration. This is sometimes the case when direct ducting into the fan is not possible due to space constraints. Inlet box dampers are parallel blade configuration to regulate and direct airflow properly into the fan. On the outlet side of the fan, dampers are used to regulate airflow by modulating the damper blades using actuation. These dampers are seen mounted to the fan with blades running horizontally and also sometimes with blades running vertically. Vertically mounted blades do tend to minimize pressure losses and they distribute the stresses associated with velocity pressures evenly across the damper. When inlet boxes are not designed into the fan assembly, vane dampers are often utilized at the fan to control the airflow entering the fan. These inlet vane dampers, such as the Ruskin model IVD, pre-spin the air to coincide with the direction of the fan wheel rotation, thereby lowering horsepower requirements and saving energy. IVD units are typically operated by use of a modulating actuator, which can be factory supplied and mounted by Ruskin. When selecting the proper industrial damper for your application, many variables come into play. System conditions such as pressure, velocity, and temperature are driving factors which will direct you to the proper product. You must also satisfy any leakage requirements that may be specified in order to optimize the system, while also making sure the materials of construction are resistant to any contaminants or corrosive present in the airstream. Ruskin offers a wide range of multi-blade control dampers which will meet or exceed the requirements of your spec. The information shown on this slide highlights the performance characteristics of each damper model in this family based on the standard construction of that model. Ruskin's standard designs can be modified accordingly to meet performance specs which go beyond what the standard construction would offer. All right, now let's take a look at an actual project which highlights a multi-blade control damper that was customized to meet the engineer's unique specs. Mechanical contractors came to Ruskin for support of this big box data center project in the Midwest, asking to provide air control solutions for their cooling tower intake and exhaust, as well as their generator room intake demands. The specs and the drawings of the project drove our application engineers to propose use of the modified CD102 industrial control damper, which we just reviewed a few slides back. The project requirements were such that the dampers would be designed to withstand a maximum wind load of 110 psf, which would limit the damper blade lengths to 24 inches based on our engineering calcs. The dampers for the cooling tower exhaust would be installed horizontally for vertical airflow and would need to fill an opening of 472 inches wide by 172 inches long. To support the work of the installation, Ruskin supplied C12 and W12 structural beam mullion supports bolted to each ship section so that the installer could span the opening with the assembly and simply secure to the concrete perimeter as necessary. Each ship section was operated by factory-mounted actuation. Specs for the cooling tower intake dampers were the same as the exhaust units, model CD102. The dampers would be installed vertically for horizontal airflow in a 150-inch by 180-inch concrete wall opening of the cooling tower room. The successful and on-time startup of this project highlighted Ruskin's ability to work with our reps and their customers to determine the proper product, to meet mandated customer milestones, and to deliver technical expertise and customer support during and after delivery. The photo on the right demonstrates our commitment to the project by providing startup support to ensure our product functions in the field as expected. For applications which require round flanged airflow control dampers, Ruskin does have a full line of products which will satisfy virtually all engineering specs, schedules, and BOMs. While at first glance, sometimes it's difficult to visually differentiate between the single-bladed CDR series of products, each model is engineered to provide a specific solution for a specific airflow control challenge. The standard construction for each of the Ruskin CDR series of dampers will cover you for the majority of your application. And on the screen you can see where it's highlighted the standard construction of a certain model, a CDR S82. You simply need to determine the system conditions to which the damper will be exposed, and also if the damper will be required to provide a tight seal to isolate the airstream when in the closed position. Once this information is in hand, you can select the proper Ruskin model excuse me, based on the performance data provided on the product specification sheet. A summary of the model's performance data on the damper's standard construction is shown here for reference. There's a standard damper model readily available for system pressures up to 40 inches of water gauge. Models designed for system velocities up to 7,000 feet per minute, for airstream temperatures well beyond ambient, and for providing minimal leakage to the blade in the closed position. Based on this information, if a tight shutoff of the airstream is a requirement, and I'm not including our bubble tight series of products on this slide, the CDR I-92 might be your choice. If you need a damper for an oxidizer or industrial dryer, which will see elevated temperatures, the CDR I-95 might be the most effective choice. When airstream isolation or containment is the critical requirement of your specifying engineer's design, Ruskin goes beyond the standard design and construction of our CDR series dampers to provide you with our line of bubble-tight dampers. These dampers have been designed and tested for performance in compliance with the requirements of AMCA Standard 500D. The AMCA Standard 500D bubble test criteria, seen here as paragraph 62255 and 6232, are applied to both the blade seal and the shaft seal to confirm the containment of the airstream is achieved. Ruskin's bubble-type products include the models shown on the screen, with the heavy-duty BTR 92 and the BTO 92 rated for performance up to 30 inches of water gauge. The medium-duty BTR 82 and the BTO 82 are rated for performance up to 10 inches, while the lighter-duty PSD, which is short for positive seal damper, is rated up to 10 inches of water gauge up to 24-inch diameter. Each bubble-tight damper is tested at the factory for compliance with the AMCA standard prior to shipment. So let's take a look at another successful project which Ruskin is highlighting its ability to meet unique engineering specs. At the M.I.T. lab in Massachusetts, the exhaust damper replacement project specified use of an industrial round damper to isolate process exhausts that contain concentrations of ammonia and fluorine fume in the airstream. The isolation challenge was achieved by use of the Ruskin model CDR I-92, providing leakage performance less than 0.7 PFM per square foot at 10 inches, using a Viton blade edge seal, material which was resistant to the process exhaust gases. The extreme corrosive nature of the airstream required the damper to be fabricated of grade 316L stainless steel and finished with Halar ECTFE fluoropolymer coating. This coating is applied using a fluidized bed coating process, which creates a finished product with optimum chemical and thermal resistance, while also creating a very smooth surface, which is compatible to the operation of the Viton wiper blade seal. Ruskin also offers more conventional and more widely used protective coatings, such as industrial epoxy, phenolic, anodizing, high-temperature aluminum, and hot-dip galvanizing when dampers must be protected against a corrosive environment. Staying on the topic of round isolation dampers, let's take a look at the Midtown Tunnel Egress Corridor project in Virginia, which involves an immersed tube tunnel under the Elizabeth River, which would connect the ports at Norfolk and Portsmouth. This project, secured and managed by our representative firm, Hobbs & Associates, specified use of flange rectangular bubble-tight dampers sized 4 feet wide by 5 feet tall. These units would be used to control airflow in the egress during normal operation, while isolating sections of the egress corridor during tunnel evacuation in the event of a fire smoke event in the vehicle tunnel. Specs drove us to the model BTO 92, which is shown to the right. 2 oval blades contained within one flanged rectangular frame, operated by use of electric modulating actuators. These BTO 92 bubble-tight dampers were constructed out of grade 316 stainless steel material, tested in conformance to AMCA 500D, and were required to be fabricated using welders qualified as ASME Section 9 criteria. In addition to this, the materials of construction were required to be traceable back to the supplying mill for conformance to the Buy America Act. The next family of solution-based products offered by Ruskin are backdraft and pressure relief dampers. These are designed to open underflow and to prevent backflow. Ruskin offers multi-blade and true round backdraft dampers constructed of a variety of materials such as painted HRS, stainless steel, and aluminum, with blades that are counterbalanced using externally or internally mounted weights to assist in opening the blades at pressures as low as 1/4 inch. This family of dampers can be utilized in both horizontal and vertical flow directions. The performance ratings of our backdraft dampers that are built to standard construction, as noted on the product data sheets, are shown on this slide. As with our multi-blade and round control damper models, the backdraft dampers can be customized to operate effectively at system conditions beyond what is shown here. Variations to the standard design can be incorporated to engineer a product which will satisfy the majority of your backdraft damper specs. Also remember that these models, with the exception of the NRBD 100, can be designed and configured to operate in a pressure relief application. In order to provide you with the proper product, Ruskin would simply need to know the system design conditions and also the pressure at which you would like the damper to begin to relieve pressure. A case study example which highlights Ruskin's backdraft damper capabilities centers on the Wolf Creek Nuclear Generating Station close to us here in Kansas City and Burlington, Kansas. This success story was managed by a representative's Triangle Sales out of Lenexa, Kansas. The owner was looking for protection of their diesel generator in the event of tornadic activity, which is a frequent occurrence in the Midwestern states. If a tornado would develop in the vicinity, these backdraft dampers, which are located in all four walls of the building surrounding the generators, are designed to open with the purpose of preventing pressure from rising inside the space and causing equipment damage. Ruskin's solution was the CBS-8, with section sizes up to 42 inches wide by 120 inches tall and customized to withstand up to 80 inches of water gauge and up to 13,000 feet per minute for short periods of time. The customized design includes thicker blade skins, heavier duty linkage, and blade-mounted counterweights. All right, an example of a product which was developed in response to the industry's demand for system protection from an elevated pressure event is Ruskin's blast suppression damper model CBSSBL. This damper has been in the market for many years, and its acceptance within the industry grows each year as a result of the successful design and dependable operation in the field. Typically used in air intake and exhaust applications, CBS8BL minimizes the propagation of blast wave into the building or adjoining space, thus protecting equipment and possibly lives. In its static position, the CBS8BL blades are stationary in the open position, held in this position by the springs located external to the airstream. The spring tension and spring location are such that when an elevated pressure event occurs, the blades are forced closed and are locked in that position through the over-travel locking mechanism shown here. Once the blast event has subsided, the locking mechanism is easily released, allowing the blades to spring back to the open position. The CBS8BL has been tested for effective blast suppression up to 44 psi reflective pressure. This damper provides protection of equipment and systems resulting primarily from dust or vapor cloud explosions. These events are oftentimes witnessed on offshore oil platforms, chemical storage facilities, military bases, power plants, and refineries. Through results of independent third-party testing, Ruskin provides our customers with an assurance that the CBS8BL will perform as advertised. Through a blast-producing process called shock tube testing, performance data on the CBS8BL was generated, which confirms the effective operation of the product. Valuable data such as peak reflected pressure, damper closing time, blast duration, and percentage of blast contained was collected from numerous shock tube tests. A recent installation of the Ruskin model CBS8BL blast suppression damper can be seen at an Air Force base in Nebraska. The blast dampers were required to provide protection against peak reflective pressures of 4 psi and were mounted either to the face of structural steel or within concrete walls at exhaust and outside air plenums, cooling towers, and in penthouse assemblies. The dampers were customized with 10-inch front flanges, or sometimes called face plates, for ease of installation into concrete walls, were constructed entirely of 304 grade stainless steel material and included fully welded security bores, or man bars, to prevent intruders from gaining access to the facility through the damper openings. So up to now, all highlighted products that I've talked about have been built using steel or aluminum material construction. Ruskin's product line also includes dampers which are fabricated using fiberglass reinforced plastic, or FRP. Round flange models for systems up to 30 inches of water gauge, multi-blade flange models for system pressures up to 26 inches of water gauge, and multi-blade and true round backdraft damper models for system pressures up to 16 inches of water gauge. Benefits of the use of fiberglass reinforced plastic include greater resistance to a wider range of caustics, solvents, and corrosives, making them suitable for odor control system applications, competitive costing compared to 316 stainless steel material of construction, and lighter weights compared to the steel alternative, making it easier for the installer. Fabrication features of Ruskin's line of FRP products include UV protection for outdoor installation. They include a low flame spread rating, includes intumescent coating for low smoke, use of high quality vinyl ester resin, and we also provide these dampers with flanges customized to match adjoining duct flanging. A project which highlights Ruskin's ability to offer one-stop shopping for FRP products is the North River Wastewater Treatment Plant West Odor Control System in New York. The existing products, including dampers, ducting, fans, and support structure, were corroding to the point where they were failing and creating a dangerous environment for workers at the facility. Project engineers determined that the most effective path forward was to replace all metal dampers, ducting, and accessories with fiberglass equivalents. Ruskin supplied the project with round models 912 and 914, multi-blade control damper model 1108AF, and even the fiberglass inlet vane damper model 851FG. Here are a couple actual installation photos that I took during my trip to this plant back in February. And on the left, you can see the line of model 912 and 914 round dampers at the inlet of the carbon absorbers. And there's a model 1108AF multi-blade fiberglass damper up to the right. So in addition to our extensive product line of industrial dampers, Ruskin also offers a wide range of factory supplied and mounted actuators, which are the engines by which automated control dampers operate. Ruskin has a strong relationship with our actuator vendors. We do truly work as partners in supplying a damper assembly, which meets our customers' expectations. Ruskin has access to a wide range of actuators, and our goal is to select the most effective, efficient, and economical actuator, which, when factory mounted to our damper, will result in a worry-free solution for end users. As you can see from the screen, Ruskin industrial dampers can be operated by use of both commercial and industrial actuators, both pneumatic and electric. For installation which require manual operation only, the basic locking hand quad or worm gear with hand wheel are available. And worm gear operators with chain wheels are also available for those remote installations where access to the actual damper isn't really possible. So Ruskin offers quite a broad range of products, including life safety products, commercial and industrial air control products, louvers, sound control products, and air measuring products as well. Offering this broad range of products affords us the opportunity to find synergies among product lines, allowing Ruskin to offer unique solutions by merging products and features to arrive at a solution which competitors can't offer. An example of this product synergy was our ability to combine our air measuring model probe AMP001 with our industrial damper models CD80AF4 and CDR82 to offer the customer a unique assembly from a single supplier, which saves money and minimizes the installation envelope. The regional Ruskin representative, Hoffman & Hoffman, worked closely with their customer to gain approval for these products, which will allow the customer to both measure and manually balance the airflow with one totally contained assembly. So this brings us to the conclusion of the webinar, and I thank you each for taking time to participate, especially during the holiday season. So I invite you to please contact me directly should you require more information on any of the industrial damper products, such as the blast damper, tunnel ventilation dampers, bubble tight dampers, or any of the generic airflow control and backdraft dampers. And before reviewing questions which were submitted during the presentation, I'd like to invite everyone to register to join the 2019 Ruskin Wednesday webinars, which are conducted on the second Wednesday of each month at 2:30 p.m. Central Time. The topics and webinar dates will be communicated shortly, and they will be posted on the Ruskin website. So at this time, if you have any questions, feel free to submit them using your control panel, and I'll give you all a few minutes to do this, and I will answer any questions that are submitted. One question which was submitted is referring to the topic of the CBSSBL blast damper. The question was, what's the difference between reflected blast pressure and side-on pressure? And that's an important point. The initial blast wave of positive pressure that makes contact with the structure, which is whether it's a wall or a damper, it's called the side-on or incident blast pressure. And upon making contact with that structure, it results in a negative phase of the initial blast wave that can be more significant than the initial positive blast. The pressure associated with this negative phase is called the reflected blast pressure. And oftentimes, the reflected blast pressure is a little bit more than twice what the side-on pressure would be. So that's a good question, and that's the kind of information you need to get with the engineer to make sure you're talking the right jargon. So you need to ask your engineers if they're referring to side-on pressure or reflected blast pressure. So thank you for that question. Okay, another question is, how is the torque calculated for industrial damper models? Well, we have in-house generated software programming for each of our industrial damper models, and that's it's calculated based on pressure, velocity, and if the damper has blade and shaft seals. So it's not like the commercial grade dampers that torque is assigned based on square footage and either 5 or 7 CF or inch-pounds per square foot. Ours are calculated based on system conditions and the size of the product and the features of the product. Okay, another question refers to the bubble tight dampers. Are bubble tight dampers valid or viable for when fluids are in the airstream? That's come up a couple times in the past. People had ordered these things when there was a lot of condensation and fluids in the airstream, and I just want to note that bubble tight terminology, as it pertains to the AMCA standard, relates to a gaseous airstream and is not relevant to airstreams which contain fluids. The fluids in the airstream would eventually seek out and eventually find a leak path through the shaft seals and could thereby create problems, especially if the airstream is toxic or corrosive. So sometimes you just have to remember these are not valves and shouldn't be used when fluids are known to be present in the airstream. It looks like one more. Does Ruskin offer performance testing with tabulated test results for purchased products? The answer to that is, of course, yes. Ruskin can offer to test dampers that are fabricated under a specific PO at our AMCA licensed testing facility right here in Grandview, Missouri. It is available at additional cost, and we do, invite people to come and witness the testing here at our facility. So if you want that done, you need to let the person quoting the job know that, and they would include the price of that in your proposal. So yeah, that's a good question. And the testing we typically do here for folks is pressure drop testing, leakage testing, high temp testing, cycle testing, And if other testing is required, like seismic testing, sometimes we contract out to another third-party laboratory who can do that. We don't do seismic testing here. We do provide seismic calculations from our engineering team. All right, thank you very much. That brings a conclusion to the webinar. And again, I thank you for attending today's webinar, and I hope you all have a safe and happy holiday season.